Let's talk about shadows and how to add those to AR. So we're going to be building this example that casts shadow from a mesh and a GLTF model. And you can see here that if we play with the position and the settings of a spotlight, that can affect our shadow. And that they look quite realistic, even when you look closer. Now, before we jump into the code, I do want to explain a little bit of what's going on technically behind the background. So since 2015-ish, the standard way of creating dynamic shadows that can adapt to changing objects and changing lights is through a technique that uses shadow maps. Now, what are shadow maps? Well, let me explain the idea behind how this algorithm works. The idea is that you basically do this in two passes. In the first pass, you render a scene from the light's point of view. All right, so you render a scene from the light's point of view. And in the second pass, you basically say, okay, everything that the light can see is going to be lit. And everything that the light can't see, so something like here, is not going to be lit, is going to receive a shadow. Now, where do shadow maps come in? So the idea of a shadow map is that in that first pass, when you render the scene through the point of view of the light, you're going to save the distances of these kind of light rays in a texture. And that's what we're going to call a shadow map. So imagine a shadow map as just being kind of the distances that these light rays have to traverse. I'm simplifying it, but just to kind of explain conceptually what's going on. And then in that second pass, you basically take a point or a surface in your scene. Let's just say that we're going to take this surface. And you basically ask the question, okay, if this current surface is further from the light than a shadow map at the same point, then it means that this area contains a shadow. So again, we're using these shadow maps to figure out if there are surfaces that are beyond the shadow map. And if that's the case, then it means that that surface has a shadow. So again, the details of this technique are much more complex than the scope of this class, but I just wanted to explain at a high level what shadow maps are because you're going to see it a little bit in the code. All right, so if we jump back to the code, we're going to start off with the scene. And this scene actually has a lot of stuff already in it that's going to incorporate all of our previous videos. All right, so it has a mesh, it has a point light that I can change the position of that will affect the shadows. It actually has a transparent plane that's going to receive the shadows. And that transparent plane needs a little bit of hit testing in order to set it up correctly. So there's already a lot going on. And then, of course, it has this debug view here. So if I go back to the code, let me explain some of those sections that are already set up for you. Of course, we have some of the GUI stuff that we covered in previous videos. We basically have a hemisphere light and we also have a spotlight, which again, we covered in a previous video. We call this function add plane to scene that receives shadows. And again, we covered this in the ground plane section. And this is just a plane that is set up to receive shadows and has a particular material that is going to be transparent. And the plane is set to be really big. So that it just covers a huge area. And of course, we have to set the position of the plane manually so that it's on top of the floor. And so we perform hit testing in order to set that plane on top of the floor. So the hit testing in this example is really just to set up our plane correctly. And then, of course, we have the actual mesh that we're loading right now, the sphere mesh. So again, there's a lot going on in the scene, and we've pretty much learned how to do all of this in previous videos. So just go back to that if you can. All right, so let's take this step by step. Here at the top, I've outlined the basic steps we're going to follow in order to use shadows in our Three.js scene. So the very first step is that we have to configure some things for the render to support shadows. Go down here to the renderer code. First thing I'm going to do is I'm going to do render shadow map enabled is true. And then I'm going to pick a shadow map type. Shadow map type. And there's a list of different shadow map types here. They're ordered from kind of least fancy to most fancy. But of course, this takes less computational power. This takes more. I just suggest using this one. which strikes a good balance and is good for AR. All right, so let's load this again, make sure we don't have any errors here. All right, that looks good. Great, so that is our first step. We have to set up the renderer correctly to support shadows. The next step is that we need a light that can cast shadows, and we need to set up that light correctly. So if I basically go down here, right, we have a spotlight. And what we need to do to the spotlight is we basically have to say spotlight cast shadow is true. So recall when we took a look at the light types video that not all lights cast shadows, right? So the hemisphere light, for example, does not cast shadow. And the ones that don't cast shadow are basically the ones that don't have a real direction. And why is that important? Is because we need an actual direction in order to compute these shadow maps. So the lights that kind of cast light in all directions or don't really have a direction, those don't cast shadows. So spotlights are one of the ones that do have a direction and they do cast shadows. And we have to set this specifically to true. And the reason is that, again, basically performing this algorithm takes computational power. And so all these shadow things are set up to false by default so that they don't take any computational power. And that's why you have to kind of set them manually to true. All right, so we have that set up. And again, if you were to have another light here, like a directional light, you also have to set that light to cast shadows to true. Okay, so at this point, we still have this basic scene and still kind of nothing is happening, but we're going to cover the last steps in the next video.